Okay, this is Mr. S. Naka Environmental Science, and this is 8.2 Part 2. We were just talking about coral reefs, and we're talking about aquatic pollution today. And so, one of the big things that affects aquatic oceanic waterways is, of course, oil spills. And that's largely because of the coats, feathers, and furs of marine mammals and birds get clogged up. And that leads to blindness, so they can't escape predators, hypothermia, and then also ingesting the oil causes diseases. So it's a huge issue. Then you have fish health and issues and death from ingestion blocking their gulls. So the oil just really kills everything. Inverts, so smothering and immobilizing all these invertebrates. And so this is an example of a major oil spill that was before your time. It happened in 1989, and a super oil tanker crashed into a reef in Prince William Sound, Alaska. And 42 million liters or 11 million gallons were released. So 500,000 birds and thousands of marine mammals were killed. And it was one of the major oil spills of this time period. And this is in the Arctic National Wildlife Refuge. So exploration could yield up to 1.4 trillion liters of oil and natural gas. And people who are against it are saying that it will harm one of the last pristine habitats and also the native population. And at the end of Trump's presidency, he opened this area up to oil exploration. In this part of Alaska, you'll see. So it's a major contentious area to be drilled, opened for offshore drilling in a very pristine wilderness refuge. In 2010, you had the Deepwater Horizon BP spill. I'm sure a lot of you remembered that. The explosion at a BP oil rig in the Gulf of Mexico. And that released 780 million liters of gasoline over 87 days. 6,000 sea turtles, 26,000 marine mammals, and 82,000 birds were killed. So this is a crisis that we're still dealing with today, and it ruined many industries and livelihoods. Tremendous disaster. And so wastewater produced by livestock operations, and now we're moving away from the oceans, right? So we've talked about livestock manure lagoons and human activities can cause a lot of water pollution. So clear water, these are the terminologies. Clear water is from a faucet. Gray water is what's coming from baths, sinks, and washing machines. And black water is what comes from the septic system. And so these can be recycled in different ways. A lot of gray water is used for like public parks and things like that. And then why is wastewater a problem? Well, this is a measure of water quality, right? And you're measuring it by the how much organic matter is in the water supply and how much oxygen, right? So wastewater has a higher biochemical oxygen demand, which means that more oxygen is required for the bacteria to decompose all of the organic material. Alrighty. And then if you have more biochemical oxygen demand, there's more pollution. That's how it's measured. So basically you lose oxygen when there's this kind of pollution from wastewater. So these are examples where of varying amounts of pollution in the Gulf of Mexico. So when there's high BOD, there's less dissolved oxygen, with many of you measured in class in our water sampling lab, present for other life forms. So we call these dead zones. And a lot of this, you can see this dead zone in the Gulf of Mexico. It's from fertilizers that come down the Mississippi River. These are all very agricultural areas. And all of those nutrients get in the water, which causes algae and other organisms to thrive and lowers the amount of oxygen that's in the water. And you can see the BOD has decreased in North America, but in these less economically prosperous countries in Africa and Asia, it's gone up quite a bit as they've gotten more fertilizers and developed more, right? So in North America, water quality legislation and pollution control measures have been installed or put into place. And in Africa and Asia, population increases and little progress in pollution control measures have caused the water to get really polluted, more and more polluted, right? And so it's a good thing to pause and read through, but these are how the dead zone areas work. Here would be a healthy ecosystem with fresh water coming in. Here you'd have where the nutrients like nitrogen and phosphorus from fertilizers will come in the same place where that river water came in. And it ignites an algae bloom. So when that algae dies, it sinks into the saltier water below and decomposes, using up that oxygen down below. And so it just becomes a place with no oxygen, where creatures can't live. And this is a huge area that is faced with this in the Gulf of Mexico, but also all around the world. All right, so I want you to try to draw, practice what a positive feedback loop is. All right, so draw that in your notes as you're taking notes here, and then ask me if you're not sure. But basically, a positive feedback loop means that it's like a snowball effect. So too many nutrients cause an algae bloom. The algae die, and the bacteria decompose the algae. The bacteria use up the oxygen, and then there's a bigger die-off. So one thing kind of leads to another, right? Here's point source pollution, if you remember from 8.1, important vocab word. You have the types of organisms here and the dissolved oxygen, biological oxygen demand when it's clean. As things are decomposing and becoming more septic, it will go down. The dissolved oxygen will go down. And then this is how the ecosystem kind of heals itself as well. So you can see the responses to these different pollutions. All right, and then lead is a huge source of water pollution as well. A lot of houses were made using lead pipes and lead paint. And these cause developmental delays in children. Even children's toys had lead. And if you had any building with lead, let's say, and say like a wall had been fallen over, the house was in disarray, that lead will stay in the soil. And so even if you grow food, your food can be contaminated with lead. So it's really important to test lead before you garden, for example. And then arsenic is another one that we've used in all sorts of, it exists in the crust naturally and in mining, and have been used in lots of different consumer products, but more of a natural contamination. You have mercury, so aquatic bacteria convert to methylmercury, which is highly toxic. And burning of coal and garbage causes mercury, and that's part of the acid deposition and acid rain, right? That increased mercury causes acidification, and it's very potent, right? So a U.S. coal-fired power plant can produce 40 tons of it every year. and only this much can contaminate a 20-acre lake. So a huge lake. All right. This causes acid rain. So acid deposition and acid rain from abandoned mines and such. You can see statues getting dissolved, and it's a big issue from these old mines and the water pollution that includes. We talked about this a lot, but pesticides are another one, and fertilizers. But with pesticides, you get the direct point source contamination that seeps in, right? But then also the non-point source diffuse contamination that will end up in the water and the leaching. And even as it dries out as like a litter that covers the earth, there's dry decomposition as well. Okay, just a few more pollutions that can get into the waterway. There's pharmaceuticals. So it's actually crazy. If you tested the Rio Grande water, you'd be able to find quite a lot of pharmaceutical medicines in there, hormones, all sorts of things. And it's pretty ubiquitous across North America and the entire world, really. You'll find a lot of hormones and pharmaceutical drugs. And then rocket fuel. So there's a huge jet fuel spill in Kirtland Air Force Base, so I'm surprised New Mexico isn't on here. But that can really affect our public water drinking systems. PCBs come from plastics and electrical transformers. They cause like types of cancer and all sorts of different health problems. And they're super persistent, so they're just like hard to get out of the waterway. A few more. So there's flame retardants and all sorts of household products, carpeting and dust, baby products. And last thing is sediment pollution. So construction, agriculture, erosion, it increases turbidity, which is that muddiness, reduces sunlight, and it can cause eutrophication, meaning lack of oxygen, and kill a lot of wildlife. Now, some of our rivers in the Rio Grande and the Colorado River Basin are naturally like that. Okay, so the Rio Grande would probably already be like that. But also many rivers, due to erosion, are unnaturally like that. Okay, that's all for 8.2. Thanks for your focus.